All right, hello everybody. Tonight is the 1st of August, Dallas Personal Robotics Group. Got our regular online meeting. Midsummer, so it might be a little bit slow tonight, but we're gonna have a good time anyhow. We're just gonna talk about our robot projects and updates and pass the mic around. And with that, I would say so far we have a queue with Ted, and then Scott, and then Open Wake. So Ted, take it away.
Yeah, okay. So I've been working on a time of flight project. It's a little different time of flight. So this one is, let me show it to you. You can see here. It's got a Decawave DW1000 module on it and ESP32 and a little LCD screen. Anyways, it's made by MakerFab, and what it does is you have multiple of these, and it's ultra wideband transceiver. So what it does is it sends out a ping, and then one of the other sensors sends a ping back, and so it measures the time difference between the two of them. So then you can triangulate your location. And so yeah, I just got these, and they're fairly accurate. It's supposed to be about 4 inches. I think I have a little calibrating to do because I'm getting more like 6 inches of distance accuracy. And the other thing I want to work on is making them ping a little faster. Right now it's about, I think, about 10 times per second. But the idea here is I can set them up. They have about 1,000-foot range, and so you could set them up on a field or something and triangulate the robot's location that way.
How much were they, if you don't mind me asking?
Yeah, so these were $55 each, and they have some shorter range ones for $40, and they have various options with or without the LCD.
So the ping is it's a radio signal. It's not light or.
Yeah, it's radio. It's in the gigahertz range. So they say for the 1,000-foot, it's mostly line of sight if you want to go out that far. But and they say it'll work indoors. I've done some testing indoors, but I haven't really tried testing through walls and stuff.
Yeah.
The Decawave module, I think it's been around for about 10 years. I've seen it, but I've never seen one on a board before. So I was kind of excited to get this and test it out. You know, obviously most contests you can't use it for, but it's still good for like testing and you know, getting data on your robot and how it's working.
Well, 1,000 feet is pretty good.
Yeah. So
and you would use that to triangulate the robot's position, just as a comparison?
Yeah, exactly. So I could compare it with the GPS or whatever I have. Just compare where the robot thinks it is and where it actually is. Because that's always been kind of a bugaboo about mine, is I can go out and test the robot and it seems to be working, but I'm never quite sure if it's actually, you know, going where it's supposed to.
Do you, are they addressable? Do you know if they're addressable?
Yeah, so it looks to me like you can just assign, when you program it, you assign it an address, and then it'll use that address when it talks to the other modules.
So the robot could have one address and it could ping one of 3 or multiple sensors and try to give you an exact position based on that.
So the idea is you mount anchor sensors in known locations, and then you have one on the robot, and so the robot's sending out ping and they're pinging back, and so, you know, between the 2 or 3 of them you can get a distance. You know, you can get your distance between each of them and then start doing some algebra and get your location, trigonometry.
Sounds interesting.
It does that through the time of flight of the radio signal?
Yeah.
Huh.
So it must have a very accurate clock because I think
Yeah.
light is about, what is it, 1 nanosecond per foot?
It's
9 inches or so
Yeah.
per nanosecond.
So I did a little bit of just testing it, and I saw there was some stuff on calibration, and I think I need to do that because it's consistently off by about 2 feet. So, just for testing it, I just subtracted 2 feet, and I get a pretty good result that way. But there is some instructions on how to calibrate it, and then some instructions on changing the pulse rate so you can get more pulses per second. And the only other thing I'm a little concerned about is if there's any lag to the, when it's reporting the signal. Because it's going from this module that does the calculations for you, and then the whole thing, it has a ESP32 on it, so that's reading the decawave module's data and then sending that USB or whatever you want.
Well, that's pretty cool.
Why do you think that 10 hertz isn't a fast enough update for location, for localizing your robot?
Well, it probably is. I just want as much data as I can get,
Yeah. But, I've kind of found that depends on your motor loop, right? How fast you're controlling your motors.
Right. And my idea, the thought isn't to put it in the loop. I'm just logging it so I can use it to test out the robot's location.
Plus, it probably beats $600 or $700 for GPS RTK, right?
Yeah, exactly. So this was, I just bought 3 of them. It would probably be nice to have 4 or 5 of them, really, but 3 you can get your basic location. And if I get a 1 foot radius, that's pretty good compared to GPS.
Mm-hmm.
Pretty cool.
Yeah.
Hey, well, I put a link in there. It looks like the right module, but if it's not, if you could put the right module link in, that would be great.
Yeah, I'll check it out. Yeah, okay. And so that's the less expensive one. The one I got, I'll put in, it was a little more expensive. There it is.
Cool, thanks.
So the less expensive one doesn't go as far, not as accurate?
Yeah, well, the difference seemed to be the power of the radio.
Oh.
So, it won't send as far.
Yeah. So do they say what it is? Is it like 100 milliwatt or something? That's what a lot of them are.
Yeah, I don't remember off the top of my head. I was just going to see, there was somewhere on their website they had a comparison of the, yeah, so it was, the measuring distance was 45 meters versus 200. But I don't see obviously, it's not obvious what the power is.
Yeah.
Well, that's very cool.
I'd be interested to see how accurate, what your results are like. I mean, that's definitely interesting technology, but man, that's got to be a very accurate timer.
Yeah. Yeah, I will keep you posted on my experiments once I get outdoors and do some testing there.
I mean, you said if there's a calibration to it, then I seem to remember, because my first electrical circuits in industry were actually laser rangefinders for for things that went on tanks, and as it turns out, like F-117, and these things used I mean, they were mil spec kinds of oscillators, but they weren't temperature controlled, regulated things. And I mean, the circuits I did in those days, this was the mid '80s. They were still LS series technology. So, but I still pushed them to the limit and ran them at, I think it was a 33 megahertz oscillator, and that could give us, if you split the clock phase, that could give us 5-meter resolution with a 33 megahertz oscillator. And from what I remember of the math and looking into it, I mean, the crystals they were spec'd to maybe a 1 or 5, just not very many percentage off from frequency. So whatever it was a constant offset, and then the drifts would just be like over temperature and such. But they were pretty consistent once you got whatever frequency it happened to be.
Yeah, it looked like the calibration involved measuring the delay of the signal through the antenna and the rest of the processor. So what you do is it looked like you set them up at a known distance and just measured, what they were reporting versus the actual distance.
Huh. Okay, and then, well, that could still explain that they might just be calibrating the variations in the crystal.
Yeah, it could be that too.
Because you would,
well, I mean, if you're trying to set a baseline at a given distance, right, you're going to be compensating for whatever lag is in the whole system.
Yeah,
whether it's switching lag or oscillation differences or whatever, right? Because you know how far a radio signal can travel in air, right? I mean, it's like you said, it's one foot every microsecond or whatever it is. The thing that interests me is, how does one radio know the baseline? In other words, when you send out a signal, you have to have some sort of timestamp in it, right? So that the receiver knows, well, it took this long for this radio to get here. Or even if they do a round trip, right? Now you're kind of averaging it, dividing by 2. So like I said, I'd be interested to see how your results come out, because I mean, it seems like that idea is wrought with problems, but I mean, it sounds like someone much smarter than me made it work. So
the data sheet mentioned a few different modes. One of them was a time difference of arrival, where you're measuring the difference between 2 anchor points, and that's not what I'm using. What I'm using is the a round trip. So it sends out a ping and it comes back. So it is measuring out and back.
And that's what we did. We would use pulse lasers, and the rise times of the lasers were like 80 nanoseconds or so. Well, picoseconds. I mean, it's pretty fast, 80 or 100 picoseconds. And then the detection circuit uses the threshold. So actually, so we would, I mean, the energy of light sent out from the laser was pretty consistent, but depending on if you're measuring something that's 100 meters away versus 10 kilometers away, the signal could get pretty well softened, pretty degraded by the time it came back. So you might be measuring the low on the rising edge of the light, and it goes out, but then you'd be measuring probably near the peak on the reflected light that comes back, and that would add some kind of variation just because the rise time of the light. But
yeah, so the data sheet mentioned about a pulse, but also mentioned a packet with a ID, so it knew which module it was being sent from.
Yeah, that makes, because we couldn't do that, of course.
Yeah.
But then we were looking for very specific widths of pulses of infrared energy, and I don't think it false alarmed very much when the analog receiver was working correctly. It false alarmed more. There was two versions. One was a solid state rod, yttrium, allium arsenide, YAG, gallium, yttrium, anyhow, and arsenic and gallium. And then the other one was a CO2 gas. And the CO2 gas was kind of cool because it was this 1 foot long cavity, about 2 or 3 inches on the side exterior. And inside it had these super flat, super well polished electrodes with very carefully contoured edges. And what you would do is you would charge up this pulse forming network. So we had a capacitor that we would charge to 20,000 volts. 20,000 volts. And then when it came time to fire the laser, we had to switch that 20,000 volts across these electrodes. And there's this highly pure CO2 gas in between the electrodes, like 99.9% pure CO2 or something. So we had to switch that 20,000 volts, and this gas would go from mega ohms of impedance to 10 ohms of impedance in like 80 picoseconds or something like that, or 100 picoseconds. So you can imagine 20,000 volts across that impedance. So it spiked up to like 800 amps for a very short time. And this is on one side of an aluminum plate, right? The laser cavity. Well, the receiver was on another side of the other side of the same aluminum plate. And what happened was that this capacitor, after it dumped the main charge, it kind of like said, "Whoa, what the hell was that?" And then it would have these, the capacitor, it had these little, was it Mylar? I forget how it was constructed, but it would continue to have little micro discharges inside the capacitor after the main pulse. And then another trouble was that when they first assembled it, like they didn't have any way to control the parts inside the pulse forming network, the PFN. So they would get up against the edge of this cavity. So you'd have like a part here, a resistor here, and a capacitor there, and some other diode or something there, and they would be right up. And then what happened was that after a while, you'd have this nice high dielectric, like potting or something in between, but it would break down the seal between the case, and it would arc inside the thing between components. So anyhow, you'd have all this, you'd have the main pulse, and we'd say, okay, the light just left. And then there'd be like, for tens of meters after that, there would be these glitches as this thing just continued to arc inside the capacitor, inside the pulse forming network. So it was causing false alarms because then that would escape, get around to the other side of the aluminum plate and couple into this receiver, because the receiver had to, we'd send out like 200 megawatts of light. And then by the time it went through smoky atmosphere, 10 kilometers, water, whatever, come back, it would be microwatts of optical energy. Megawatts out, microwatts back, and we would detect it. So, boy, that was, and that's where I cut my teeth as a double E, was figuring out electromagnetic compatibility, which involved a whole bunch of stuff, right? Because one was redesigning the pulse forming network so it wouldn't track along the case inside, and another was, like figuring out if it was radiator or conducted emissions that was doing in the receiver. Oh, and the other fun thing that happened was, so the receiver, however good it was, it had trouble rejecting switching power supply noise. So what we actually did was, there were custom designed power supplies. So they actually shut off the switching power supplies before they take the range measurement. And the circuit that I designed for the stopwatch had to run off of capacitors. So it ran off capacitors for 100 microseconds. And then the power supply came back on again. That was pretty fun.
That sounds cool.
Okay, anyhow, that's my story. And it was all time of flight. Since then, I've learned that, they have, like for measuring velocity, they'll do Doppler, they'll measure phase shifts in the RF, or I don't know if they can easily measure the phase shift in light, but yeah. Okay, that's my non-update update. How about you, Ted? Any more?
Oh, let's see. You had asked about the oscilloscope behind
Oh,
me.
yeah.
So I found a video series by Ben Eater. If you've heard of him, he was doing a 6502 based computer on a breadboard. So I decided to try to duplicate his project, which was kind of fun. But yeah, I needed to figure out some of the timing there, so I brought out the scope.
That's pretty cool.
I
How
love
far are
these-
you on your...
I love me some Ben Eater. He's awesome. He literally starts building a computer from he puts a chip on a breadboard and starts doing wires.
Yeah, well, he did another project, where he basically started with transistors and TTL logic chips and built a computer.
Oh, that's awesome. That's awesome. You're asking a question. I'm sorry, I stepped on somebody.
Well, Ted, I got an oscilloscope story today. When I'm going to take a turn, I'll get on the queue and I'll tell you my oscilloscope story of the week.
Cool.
It was not a good one, but I'll tell you about it.
But so this is probably about a 20-year-old LG scope that I bought used 10, 15 years ago at a college auction.
Very cool. So will you show the your 6502 thing when the time comes, when it's ready?
Well, yeah, this is what I have right now. I'm hooking up, this is the 6502, and I'm hooking up a EEPROM to it.
Okay.
I still have the data lines to put in.
Very cool.
That brings back a lot of memories.
Yeah.
Back when robotics was tough. You know, you're going to program a robot. Well, you had to build the CPU to run the robot.
Yeah, back in those days, I'm like, this is too hard.
That's actually another thing I remember from the mid-'80s in the defense world is because we had to use parts with established reliability. So we were using ancient, decades old parts because we had to. And then someone was I was asking, why don't we use a microcontroller? And well, because it's not proven yet. We can't justify it. And then they started to explain that for some space applications, satellites and such. This was the day when bipolar was still pretty common and CMOS was just getting its roots in the ground. And they were explaining that the 6502, you would find it in the satellites versus much more modern processors, even in the day. Why? Because I guess if I remember right, the transistor, the fundamental process, the transistor size was relatively large, and then that made it relatively tolerant of the radiation you get outside of the Earth's atmosphere. So they had to design the circuits to tolerate getting zapped all the time from radiation. So you want to put stuff in space, that's just another design factor. Which in a way I think was similar to what happens when you design things for EMP, which we didn't have to do as much of, but it was there. Anyhow.
Can you actually design things to withstand an EMP?
Oh, absolutely. There's specs about it. You have to, right? Your tank, you can't just have your tank fail. That's what the Detroit Auto is for. So do you know what the trick is? Because we did spend.
Don't get bombed by a nuclear device.
Well, that's
right.
Capacitors? Big capacitors?
With the obvious. Come on, Captain Obvious. Yeah, there you go.
Nope. And it's funny because my wife and I just saw Oppenheimer last night. So this is all dredging up memories. But the thing is that.
No spoilers.
No, I'm not gonna. No, this is all double E stuff from
The bomb worked. Oops.
Distance past. So here's what happens. As I remember, and this is there's many ways you can get zapped by the bombs, right? Because there's the radiation just destroys your cells. There's the heat and the pressure wave. But then there's the one that just takes out whole regions worth of electronics. So that's where they instead of detonating the bomb like however high they did over Hiroshima and Nagasaki, they detonate it much higher in the atmosphere. And when they do that, if I remember right, it like has some effect of ionizing some layer of the atmosphere. So it superimposes this giant electrical field across anything that conducts electricity. So basically, it's gonna crowbar everything, or it's gonna turn on all of your transistors at once. So you think about CMOS, where you have a pull up, one transistor to pull up the output top, the other transistor to pull the output bottom, and they're straight. There's no resistor or anything. They're straight across the power supply. So what happens is that if that EMP ionizes the atmosphere, it turns on both of those transistors. You get the full battery across both output transistors, and what happens is that just burns them out. It fries them. So it's gonna fry anything that's not designed to tolerate that. So what you do is they have special kinds of circuits which can detect that kind of an event. And I mean, you can't turn off a power supply that quickly. You can't drain off power supply decoupling caps that quickly. But what you can do is basically detect the event and crowbar the power supply so that your crowbar takes all of that energy instead of the transistors you're trying to protect. And then the system, after that pulse goes by, then the system's supposed to recover. But they have tests for that. I think they have like chambers. So you take your subsystems and circuits into those chambers and they zap it, right? So
one problem I heard, Carl, was that you'll get secondary like echoes that come back after it gets crowbarred and hit it as soon as it comes back up.
I don't doubt anything like that. Yeah.
Yeah. So then
all I know is
they had to hold it down for several minutes to get everything to work itself out.
Dissipate.
Yeah. I didn't get that deep into that part of the design, but it was pretty interesting stuff at the time, and just all the more reason to just let's not get there in the first place, right? Yeah. Cool. Okay, so our cue is Ted, and I guess, is that it, Ted?
That's it for me.
Okay, cool. So then we had next Scott, then Doug has an Oscilloscope story of the week, and it's not a happy ending, but we'll try and lift them up. And then it's Jack, and then it's open mic. So Scott, take it away.
Yeah, well, as you can tell, I've got the sensor array for turd here, working on it. And so I got some pictures I was going to share. I can figure out how to do that. There we go.
That's so clean and organized. How can that be?
Well, you know, it was staged so that I could take some pictures.
I mean, there's got to be some kind of star for the cleanest workbench on the planet.
Well, you know, like again, this was staged, so
okay.
You know, I wanted it to look nice, right? So
okay,
you know, a lot of people ask me about, you know, building the different components and, you know, the assembly. So I thought I would try to document a little bit about what I'm doing with this. And so this is basically the whole enclosure thing broken out. And these right here on the table, these are time of flight sensors that I've been using at work. They're all I²C. Printed out some 3D holders for them, and then I've got some lenses that I made for them as well, some smoke lenses. And actually, I reused the sensor array that was on Burp, which is what all these parts right here are. Although I had to remake the bottom. And you can kind of see the time of flight sensor in this picture. Pretty nice little setup. I've got them, you know, you were talking, Ted, earlier about the time of flight and the resolution. And these things go down to centimeter. They have a couple of different ranges, similar to the radios, where you can kind of adjust the output pulse from them. So you can do short range, mid range, or long range, but you start losing accuracy and also resolution. So the mid range that I'm using is about 6 meters, which for obstacle avoidance is fine, because that's all I'm using them for, so I don't run into anything. Of course, this is Turd's chassis, which I really haven't done much with. And then you can kind of see all the pieces put together here. This is the back of the time of flight. I've got a little pixie cam that I used off of Burp as well, just for the blob recognition. And so this is a little stanchion that it mounts to. This is one of those been awake time of flight sensors. I think I won it in one of the contests. So it talks to the CPU over CAN. And this is what it all looks like put together. So I'm just now trying to get all the software written and interface it with the Raspberry Pi that's running on this thing. And I also got one of those cheap, I don't have a picture of it here, but I got one of the inexpensive WIT AHAR units off of Amazon. They were only like $100. One of these guys here. And it seems to be doing pretty good. There doesn't seem to be much drift to it. So, Ray, I think this one's going to take second place in the Robo Columbus. So, you know, you may have to settle for third.
Ooh.
But that's kind of what I've been up to. Just trying to get this thing working.
So that other sensor that you mentioned,
This guy here?
I just heard WIT. What's that?
Been Awake is, they make sensors and whatnot.
Oh, it's a Benawaki like that? Similar sensor to that?
Yeah.
Oh, okay.
I think I bought it from Robot Shop. So, like I said, I haven't even used it yet. I mean, I got it talking over CAN. I mean, it seems to be pretty accurate. It doesn't drift. And I was going to use, just a fifth time of flight board like the other four, but they all run on an independent I2C channel, and I only had 4 I2C channels on the micro I was using. So I kludged that like a tumor on the front. But like I said, it seemed to work pretty good. That's kind of the way I had Burp set up, so I can use a lot of the same algorithms and obstacle avoidance, as far as how do you react to the different sensor inputs, turning left, turning right, that sort of thing. So,
So do you aim it, is it just aimed horizontally straight ahead? Do you aim it down and also can see stuff lower on the ground, or?
No, on Burp, this turret, I could adjust it, right? I could turn it up and down, but I didn't want to put that much weight on this. This little RC chassis really doesn't like a lot of weight. So I just kept it I found actually the time of flights that I'm using here have a cone of about 30 degrees. So, you get a pretty good vision of it. And, I think I can run over pretty much anything that I can't see. So,
Okay. That's a pretty good sized cone for light, but I guess
it's actually what is called a spade array. So it has an array. It's not a single projection, right? It's a 16 by 16 array. And you can actually adjust what they call the region of interest. So you can look at all 16 by 16, returns. And one thing that I've discovered with time of flight is it's an average, right? You don't get an absolute. So for instance, you have a cone that's say 1 foot square, and you're looking at an object that's 6 inches wide. Okay. You're not going to see that shortest return to that object. You're going to get an average of that 12-foot section, or that 1 foot square section, right? So whatever the background value is, that's going to be added to it. So you're going to always get some sort of longer reading than what you're really looking at. But in my case, I'm just trying to keep from running into something. Yeah. So I really don't care exactly how far away it is, as long as I'm not right on top of it.
Right, as long as you know there's something there, then you can avoid
it. Something I need to go around, or that I can't go over.
Yep.
So we'll see how it does. So,
Scott, Kareem asked a question about your HRS sensor. Can you just take a peek at that link and see if the one he found is the one you're using? At some point.
Chat there.
Yeah, and in the chat, Mickey Dean's giving you some thumbs up on the presentation, so nicely done.
Wow, those have gone down a lot in price since I last looked at it. It seemed like it was $150 or so for that sensor, so they're getting cheaper.
Yeah, it's the link. I've got the HWT 905 TTL, and when I bought it a couple of months ago, it was $99. It looks like it's $129 now.
Well, to be clear, the last time I looked at it was like 4 years ago. So,
well, and they've got some cheaper ones, but I like this one because it had mounts to it, and it also had the TTL interface that I needed, so that you're not dealing with USB or 232, because I can just plug it right into the pins on the micro as far as the UART on there, and the software, and you can actually, because I have a little program, you can configure it and you can visualize it, and calibrate it. But you can set it up to where as soon as you hook power to it, it just starts spitting out data. So the software on your robot, you don't have to worry about reconfiguring it every time you boot up, or initializing it, or calibrating it, or anything like that, because it's all static.
Yeah, so the real question is, how does the compass work without calibration?
It's pre-calibrated.
Oh, okay. But I mean, you don't need to calibrate it to where it is on your robot or anything?
I hadn't got that far yet. Okay. But just playing around with it, no, it seems to be pretty accurate. You have to add the magnetic offset for wherever you're at. You got to do that manually, because it's pointed to magnetic north, not true north. So But that's really the only offset that I've seen. And it's stable enough to where, because I really only use the yaw, right? What direction do I need to head to get to this GPS coordinate? And as long as it's stable and doesn't drift around, I can always add offset, to zero it out, which is the same thing I do with burp. I basically, I'll tell it to go to that coordinate and let it run. And if it's not pointed, and I'll adjust the IMU either mechanically or, the offset in software until, it runs straight for the cone. So that way I know when I go to wherever the starting line is, the compass is calibrated correctly. And when it takes off, it should head straight for the cone.
So why'd you choose that over like a BNO 055 or 085 with column
I think
ring and
this one is much because you don't configure it, right? So once you define the calibration and what data package you want from it, you just put power on it and start getting data.
Okay.
And the problem I had with the BNO 55s was, getting the reference, right? The magnetometer seemed to drift a lot. And then basically the way I ran it last year on Turd was I used it absolute. I turned off the magnetometer, but when I powered up the robot, I made sure it was pointed north. And that seemed to work better than trying to calibrate it and use the magnetometer and all that. So,
Yeah, the problem I had with the magnetometer on those is, you have to spin it around to get it calibrated. And even once you get it calibrated, it has a self-calibration routine that will occasionally kick in, and it'll change your heading by 10 degrees all of a sudden, or 15. So, what good is that? Suddenly, my heading's different.
Yeah, I use the BNO 55 on my CAN robot as well, but I use it in magnetometer turned off.
Yeah.
Right, so it's just in relative mode. And the same thing applies there. When I turn it on, I set it down and point it from one gold straight to the other, and then I turn it on. Right, so that's 0 degrees, if you will. So even though I use my LiDAR to triangulate off of the walls of the course to update my odometry, my direction and my, where I'm pointed still comes from the BNO 55. And it seems to be pretty stable without the magnetometer because, it's mounted right next to the motors.
Yeah, without the magnetometer, it still drifts, but, that's over a period of minutes.
But overall, I think the 55s are really pretty decent. I'd like to say it seems to work pretty good on CanMan, so.
Oh, cool.
Hey, Scott, before we leave, I wanted to ask a couple of questions about your robot base. Because when I was messing with mine, which had a similar RC car chassis, and I found that I was struggling with the weight. I did everything I could to beef up the spring. The springs and the dampers. And a question I had is, how much does yours weigh? And have you run into that problem yet? Where it just sags down to it's almost bottomed out.
Yeah, absolutely I have. And that was what I was mentioning. That was why I took the pivot articulation, off of the sensor head. It's all built with the thinnest aluminum that I could get away with. And here, let me share again here. I'll kind of show you. I was lucky that if you notice, there's dual shocks on here. This was a gas nitro car.
Okay.
and I bought it, second hand, and the guy that I bought it from had put a lot of high performance parts on it. But I ended up going down to Ace Hardware and replacing a set of the springs, which I'm going to have to, once they restock, I'm going to go back and I'm going to replace the other set in the front, because you can't really tell. Here you can kind of tell, you see how it's pitched down, and that's just simply because of all the weight in the front. So yeah, absolutely. No, I haven't weighed it. I need to, but yeah, weight's an absolute killer on these chassis, because they're not meant to support weight, right?
Yeah.
I mean, they only had a little thin plastic body on top of them.
Okay.
Yeah.
Okay. I was wondering if you had some secret sauce that was allowing you to do it. And
Bigger springs.
yeah. I've also used those what is it, WIT sensors, but I've only used their 6 degree of freedom one. It seemed to work. It was pretty easy to play with, and like you say, it's all nicely packaged. And at the time, it wasn't that expensive.
Yeah. Well, like these, they the one I got is in a little metal or aluminum enclosure. It's got tabs where you can mount it down.
Yeah.
It's got a really nice cable gland. It's what is it, IP83 or whatever, for dust and water proof kind of enclosure. So so far I've been happy with it.
Cool.
They call it military grade.
Yeah.
Here I can.
But it's another one of those sensors like the B&O, the 055, where they've put in a filter somewhere. You're getting a filtered result, so you don't have to screw with it, if I remember right.
Yeah.
And it's EMP proof.
Yeah. This is the one that I'm using right here.
Yeah, that's much more expensive than the one I had. Mine had a plastic case, and like I say, it was only 6 degrees, and I think mine was an MPU.
Yeah.
6.
And they've got this software that they sent you can download. It's really pretty nice. You can do a lot of the visualizations.
Now,
you can visualize some of the calibration data, a lot of the raw data. They even have models where you can integrate like GPSs into them.
Right, that's what I was going to ask you next. On yours, does yours have pins to bring in the GPS signal?
No, this one does not.
Okay, because some of them have a where you, like you said, you can actually add the GPS into their model.
Right.
Yeah. Okay. So.
And it'll, they claim that it'll, the data is integrated, right? So they know that, if the GPS coordinates have moved from this point to this point over this period of time, right, your accelerometer data and your IMU data should match.
Yeah.
Right? So they tie it all together.
Right. That's what the common filter will do. Yeah. Okay, cool.
Very nice. Okay, I think, so next in queue, Doug, we have your Oscilloscope story of the week, then Jack, and then a bunch of people have joined, but at the moment it's open mic after Jack, as far as I know. So Doug, what's been going on? How are you doing? Aside from a bad microphone.
You're on mute.
Following your Oscilloscope.
Okay. When I say go ahead and pin me, and I'll try to do this as much as I can without actually sharing. So I'm going to save the O story for last because I always end up with a. But anyway, I've been messing around with this part here.
Is it teensy?
No, not the teensy's there, but this is a GPS with a 5883 magnetometer built into. It's made for clones. I mean, not clones, drones. They're made for drones. Okay. So you can see it's very, very small.
So clone drones?
And one of the nice things about it is it's using the 10th generation. I'm sure it's a licensed part. I don't think it's made by U-Blot, but it's the licensed part of a 10th generation GPS. Then you can actually test it out on using U-Center 2, not U-Center, U-Center 2, and which is the U-Blot software for messing with things. And you can also record your session, so you can let it sit there and run for a couple of hours and then download that session and then put it into U-Center, and you can use all of the U-Center tools to look at it. And so you can see my room here, okay? I've got a big window on that wall, all right? A half window on that wall, but I'm on the edge of the house. This is enclosed in part of the house. Setting this here in approximately the middle of this room, I was able to get from 15 to 18 satellites pretty quickly. And from at least 4 of the GNSS constellations. So pretty good GPS, okay?
Hey, Doug, what time of day have you tried that on? Because I noticed on mine, the time of day is very dependent on how many. Probably around the middle of the day. Okay. I'm
retired, so it's probably around the middle of the day, around lunchtime. Yeah.
If I were you, I'd test in the morning and evening and at night because, one of the robot projects I was doing a lot of testing at night, and I was getting great GPS signals. And then I go out to the contest in the middle of the day, and I'm not getting any.
Yeah, this was in the middle of the day.
Yeah.
But you're right. But I think the thing what impressed me was that with this little tiny, ceramic antenna.
Yeah.
No ground plane.
Yeah.
It was doing darn good. And so, I tested the 5883. So that's what the Teensy's for. The Teensy's actually being used to test the compass chip. And, I'd taken in the different people's, first of all, I'm not a big fan of the compasses, but I wanted to see if this one would work. And it actually worked pretty well. You have to calibrate it. But once you calibrate it, I sat it in the same location and left it there for about 36 hours. And then it varied approximately, I had it pointing south, and it varied plus or minus 2 degrees, and it stayed there pretty constant for the whole time. So, which I think for a compass. Now, this was so to test it to a little bit further, I used some distressing tools. Okay, so I've got this guy. Imagine this guy. He's sitting on my table, and he's sitting there, and so I'm actually watching the readings. I'll flicker by on my PC because I've got the Teensy just serial porting over. So the first one that I used distressing was, how close could I get with a piece of iron?
Uh-huh.
And that was interesting. If a disc was 18 inches away or more, it seemed to be okay. But, you got any closer than that, and you're going to have some major changes going on. So that
Get even closer with it spinning, and that'll be real distress.
Yeah.
Yeah.
So then I used my second distressing tool, and this one is, to help kind of simulate motor noise. And this thing would definitely have to be I don't know how they use it on a drone. It would seem to me with 4 motors running that close to, maybe it's a big drone, I don't know, but it seems like it would be a problem. I know this guy probably makes no attempt to suppress noise, but I found that if I got within about 8 inches of it, I could change it. So anyway, that was my 2 tests. I was able to, the links that I supplied last week were actually pretty, really the basic, the first one was the most useful one. And it had a little, I was using the 5883 compass library that's in the Arduino library manager. And I also I took that and made some small adjustments per that YouTube video I told you about. And like I say, I was actually I'm still not a big fan of compasses per se, but I got to admit that it did do pretty good, and I was surprised. Okay.
So I have a comment about just leaving it sitting on the desk. If it's not moving, it's a lot easier for it to. I understand. Like the BNO 55, well, it's not really lying to you, but it has this idea that if it's not moving, the direction isn't going to change. And so it will tell you the direction isn't changing if it's not moving. Right, because in that case, they're using filters. This isn't using any filters. There's no filter. This is a magnetometer. Okay. And so that's so I was really a measure of the sensor. Mm-hmm. All right. Now, then you know how Ray likes to use fairly large motors. He's always got big motors, and some of the other, I've seen other people, look at the larger motors, and I came across something that I didn't know existed. I don't know why I didn't know this, and maybe this is old hat and everybody knows this, but I thought this was, I'm going to share. So how do you add a encoder to those large motors, assuming there's something to stick it onto? All right. Let's see. Select a tab. Yeah, here, let's try this one. Okay, are you guys seeing this Amazon picture? Yep. Okay. Well, it turns out that golf carts have a speed sensor on the back of their motor, which is essentially, if you get the ones that are standard, there tend to be this little magnet here, and they're usually 8 poles. And you have to, you can see the price is pretty cheap. So the sensor, it's a Hall effect sensor, is actually up in this little guy. Okay, and it's not quadrature or anything. It's just, it's just a speed sensor. But this could be a solution. And if you had to, you could even put a shim inside here to reduce the shaft of the magnet. Okay. For $13, it might be something that you might want to look at. Now, you have to be careful. There's a trick to this. Let's see if they've got one down here. Oh, see this one right here? It says Club Car High Speed Magnet. Well, what they do, and people who own golf carts, they want them to go faster. So what they do is they get a magnet that has less poles in it. And so
the controller thinks it's getting less ticks, so it speeds up the golf cart, and they can get about another 3 or 4 horsepower, I believe. And those magnets, depending on which one you get, will be 2 or 4 poles. So anyway, I thought this was cool. Like I say, you guys may all know about these things, but I had not ever seen that. And so, where is it? So anyway, I decided, how do I stop sharing?
That's pretty cool.
Here it is. Okay, so that's the second thing. All right, now the third thing I wanted to talk to you about was my SAD O2. This is okay. I've been working on my little router, the one this guy over here. This guy right here. And you can always, you see the covers off, that's bad. When you see the covers off, that's bad. Anyway, so I was seeing here, I was trying to mill some aluminum. And I was getting where when I tried to mill the aluminum or anything, I was getting where the controller board was resetting. So I've got noise coming from somewhere. So I kicked out the trusty oscilloscope, and first thing I did was try to figure out how to make capacitors to all the leads, and see if I could cut it out that way, but it's going to be a bigger problem than I originally thought. But anyway, back to the oscilloscope. So I took my oscilloscope lead right here, and I did this blue capacitor is between the red and the black. So I put one here and one here.
Hey, Doug, you're blocking your camera with something.
Oh, okay. Can you see it?
There, that's better.
Okay, so I put it across the red and the blue line. I know better than this. This is an isolated supply going to this guy. And here I am connecting it to earth ground. Well, it blew the fuse in the box just completely out of, it was so, one of the things that you need to make sure that if you are trying to measure, and the other thing is the voltage on this thing is 100 volts. So, it's a pretty good voltage, so you got to be kind of careful about how you do it. But what I should have done is use 2 channels, not hooked up the ground, inverted one of the signals, and did a differential voltage on the oscilloscope. So I'm just saying is, if you don't, if that all sounds like Greek to you, you probably need to read up on. That's one oscilloscope trick you should know. And I knew it, and I still did it wrong. So you just got to be careful that when you hook that ground wire to something, to know what you're exactly doing. Well, like I say, blew the fuse. Well, without Tanner, I guess I could have gone down to Micro Center or Auto Stop or something and got it. But I was traumatized enough that I decided to get a selection of fuses from Amazon so that I can do. First of all, I'm going to do 2 things. One, I'm going to lower the fuse value, and hopefully my power supply is not zonked. If it is, then they're got to go buy another power supply. But hopefully not. And so it could be an expensive mistake. So anyway.
Well, hopefully the fuse did what it was supposed to.
Yeah, it did, but it was a 15 amp fuse.
Yeah,
so and it smoked. I mean, it did. And I'm like you say, Ray. I'm an optimist. I have hope. Yeah. But God Almighty.
And the other thing, those that don't know, you can float the scope. So you
that
get
was
one of those
yeah.
3-prong to 2-prong adapters, but
That
you have to
would've
watch
worked.
out because now your case of your scope is whatever potential that ground lead is connected to, which
right.
can be
Well,
linked.
that's that I'm aware of that because that's the one on my old scope. That was the only way I could do it.
Oh, okay.
This one, with multi channels and stuff, I can do the differential. But you're right, that does work. But this one's up at 100 volts DC. God knows where it really is. You know what I mean? Compared to ground, so. It was enough that ground was able to put 15 amps through it. So anyway, we'll see. Yeah. So that was my sad O-scope story. And I think that's all I had. You can unpin me now if you did. Okay.
Well, is it my turn? I think.
Yeah, I think you're up, Jack.
All right. So
Anyway.
I think the machine's ready to make a chocolate milk finally.
Okay, wait a minute. Got to pin you. Okay.
All right. Let me get everything ready real quick. All right. So the one thing I will be doing myself is adding the milk to represent the coffee machine. So it's grabbing the cup. Can you guys see well?
Yeah.
All right.
So it doesn't milk the cow.
No.
Uh-oh. Wait a minute. What is this? Hey.
All right. So here's my part where I add the milk.
He looks frozen. He's frozen up. Oh, there he moved.
Oh, there it goes. Yeah.
Oh,
Oh, did I freeze?
yeah, you froze.
Oh, okay. I was just adding the milk to the cup right now.
Okay.
And then we'll add the syrup. So this part actually takes a while because I currently have an underpowered pump. So I do need to get a more powerful peristaltic pump.
So this is putting chocolate into the cup.
Yeah. Not sure if you guys can see the chocolate coming out.
No.
No, not really.
Is it?
Oh, wait a minute.
Over here.
How are you going to dispose of all that chocolate? I wonder.
The fun way.
Okay.
Jack? So he's going to do a Simpson.
Am I seeing something going up and down, or is that just my imagination? Down just above the cup. Is there a...
Shouldn't have been.
Okay.
Yeah.
I kind of picture Homer Simpson, at the 7-Eleven on the Slurpee machine, That's how you get rid of the excess chocolate.
Mm-hmm.
You must like yours really chocolate-y, right?
I'm sorry?
You like a lot of chocolate in yours, right?
I do. That might be... It might not be the pump's fault that it's not coming out quick enough.
How do you measure quantity?
Trial and error currently.
Okay.
Well,
time.
I'll have something more...
Taste.
I can't think of the word. Reliable when I get the final version.
So it might be like the Tesla with the ludicrous setting, you have Jack's setting for chocolate that's like equivalent to the ludicrous.
Right, yes.
Is that ludicrous speed? Not hyper speed, but ludicrous speed?
Right.
All right. That was before That's before Conrad was born. But anyway,
Should be done by now. Okay.
Is that like a hot milk glue gun up on the pegboard, or is that part of the process too?
I'm sorry?
That green
Oh.
thing?
Oh, yeah, that's a hot glue gun.
Oh, okay. It's not.
I feel like it's been more than a minute.
Yeah, it's been more than a minute.
Oh, dear. Hope I didn't accidentally add a 0.
Really like that chocolate.
Okay, let's see. 1, 2, 3. Should be good. Okay.
That was the setting where there's a splash of milk with the chocolate, right? Mostly chocolate. But, yeah.
All right. Okay. Did I must have messed something up. I don't know what I did. Oh, dear.
When I'm chugging chocolate, I don't want to turn it off either.
I think I might have to stop it. Man, come on. Yeah. Well, I don't know what happened there. Okay, I'm just gonna go give it another try and go back to my old. Actually, I'll just skip the syrup part since I clearly have enough syrup now. Maybe.
Do you though?
Sorry?
Do you though?
Is that possible to have too much?
Actually, I think that might be a little problematic, so I'll just go back to the. I'm gonna re-download it real quick. Don't know what happened there.
Demo effect.
Yeah, definitely. All right. Oh my, yeah, there was a lot of chocolate in there now.
You planning to have some kind of mixing function?
Yeah, the mixer will be over here. Okay, there we go.
Oh, it froze again.
Raise it into the mixer.
Darn. There we go.
Is it mixing now?
Yes, it is. I'm sorry. Yeah, and then I'm going to keep my hand by it just in case. Now it's adding the cap on top.
Okay. Whoa.
And now it's going to press the cap on top. But doesn't look like. There we go. Okay.
I like the sounds.
Oh, thank you.
Yeah.
They're a little terrifying for me, but
Sounds like robots.
and there we go.
Ta-da!
Yeah.
That's some major star action, isn't it?
Yeah. Oh, yeah.
All right. Oh, so I think that was 4 years. So now I think the next plan will be, I'm going to put this aside for a while and I'm going to work on the app for it.
Oh,
And then,
Oh.
yeah. And then after that, then I'm going to have the full metal version.
That's cool. And what do you call this first part of it, or the whole project?
I'm sorry?
The name? Do you have a name for this project?
Well, I've been calling it Benjamin, but I've been thinking about changing the name. Not sure.
All right.
Yeah, I was thinking maybe Hector. I'm not sure.
All right.
Got to think about that a bit more.
All right.
Yeah.
So, Jack,
Yeah.
are you going to add coffee and chocolate? So they're going to be dual purpose?
I was hoping to have multiple syrups. So if you wanted a mocha, you'd have, I guess, the mocha syrup. And it would do both. But, I need to spend the money to get the expensive coffee machine for the coffee part. And I was also hoping to have sugar and maybe some different flavored coffee syrups. But aside from that, I do want to see how it tastes. This is my first one actually tasting it.
Oh.
Need more chocolate.
Oh, darn. You have to
Take two.
I do need to figure out what happened with that. Because it was only supposed to be a minute. And I counted the amount of milliseconds I thought I added and it was a minute, but...
Well, that's looking cool. Oh, no. We lost him.
Is he back?
Join back again.
Yeah, I accidentally left the meeting.
Okay.
Well, that was all I had to show.
That's all. That's pretty good.
Thank you.
Yeah. Okay. Well, thanks. I think after that, we were to the open mic part of things.
Okay. So I have something to mention.
Okay,
know
there
this.
you go.
Speaking of open mic type thing, so what I know is on the makerspace site, since we have milling machines, seemingly people do. So I don't know if this might be of interest for you all, but I will share a screen if I can present. If I remember where I need to click for that. Come on. Present now, a window. And that's the window I want. So they have a teacher at a high school that seemingly has had a milling machine. So I don't know how big these things, well, this one is, but it looks pretty big. So, but he certainly needs help with it. So anybody of interest on milling, like Ray or that, there's this.
Where is Crum, Texas?
I'm thinking up near you.
It's up by
somewhere.
Denton.
Oh, okay.
It's very close to Denton, north of Denton.
North of Denton, okay. Yike.
Well, maybe not as close as I thought to you then. Sorry.
No.
Because you say Louisville, but actually, and who knows how many times per week he's talking about. But
He says he lives in Crum, but he's located in Louisville. So maybe it's not quite as bad as Crum.
But anyway, seemingly is a big mill machine.
Yep, it's pretty big.
It's a picture less big.
Looks like it may have looks like it's got a DRO and maybe a CNC controller, or is that just a?
It could be just a display in display.
Yeah.
That's my thought.
Yep.
But for whoever is interested in those type of things, so that's just FYI info. And that's unfortunately all I have. There really wasn't anything out there to share on Thingiverse. There was something I thought I saw, but I didn't see it now. So, otherwise, if I see it, I'll bring it up probably next week. I don't see it offhand this week, but basically it was a 3D printer, good design using the cheap little yellow motors as its base. And it was like a soccer type vehicle. But as I say, if I see it, I'll bring it up next week on that front. That's unfortunately all I have for today.
All right. Well, thanks, John. So again, we're back to the open mic. So
Hey everyone. So this is my second meeting I'm attending. Some of you remember me from the last week. Yeah.
Welcome back.
Yeah, thank you. I'm the one trying to build a robot, but has never touched anything in my life. So I know that I'm sorry I have to switch off my video. Last week I said I'm trying to build a quadruped, but I changed my mind, of course. I'm trying to build a four-wheeled robot car to begin with, right? So I have a couple of questions to everyone on this call, right? I mean, who has worked on something similar. Is there any robot kit or something that I can go get from internet and then start playing around with that? My couple of my requirements are like it should be omnidirectional, it should be able to move in any direction easily. I can take care of the programming and all, and it should be able to carry some 20 to 30 pounds of weight. I'm trying to put some rod on top of it and hang something on top of it, like a mannequin kind of thing on top of that robot car. Right, very small space movement, not like I'm not going to make it run around the arena or something, but in a room space kind of thing. Any ideas, like where do I start?
How much do mannequins weigh? They could be pretty heavy, right?
I just said mannequin, but it could be like much lower weight, like 20 to 30 pounds should be okay.
Oh, okay.
Yeah,
that's pretty big.
Oh, okay. Because I saw online and Amazon is selling some chassis omnidirectional that can support 16 kgs. And I tried to place an order, but it will come only in September or something. I don't know, like, is it true? Is that, let me try to pull that up and share it here. But yeah.
Yeah, I guess I've seen some of the, it's in kilograms, so 20 and 30 kilograms, which is, 2.2 pounds per kilogram. It's a fair amount of weight. Carl, they're similar to your platform, but, with beefier axles and stuff. Have you ever looked at those?
You mean me?
Yeah.
No, I was going to say, I mean, amongst the club, I think isn't it pretty much, Ray, just you and maybe Pat who do these 16 kilogram sized kinds of robots? I mean, most of the rest of us are doing, I'd be surprised if they weigh 4 or 5 pounds.
Yeah, a couple kilograms.
Yeah. So
Yeah.
most of us do the smaller ones, and they're definitely less expensive, easier to access kits in the lower weight ranges.
Mm-hmm.
And if they're going to run into something, they're less likely to break something, I think. But
I will not be taking it outside. My requirement is that I will be running only on a plain ground within a controlled environment, within 4 walls. It will never go outside. I'm not expecting it to run on the dirt or anything. Very simple use case. But I need the weight support, and there might be motors rotating on those weights, like I'm trying to hold a fan or something on top of it.
yeah.
So yeah, I mean, I know that makes it more complicated. Can I build something like that on my own, or like would it be too much of a trouble to do that entire calculations and all?
I mean, why not? What places did you look for platforms? Was it only Amazon or?
I looked at the mouse electronics, but they didn't mention their weight specifications, so I don't know if I should go ahead and buy it. This is the one I found. Let me share it here.
Oh yeah, the
yeah.
Mobius. That's exactly the platform that I've used.
Right.
Sorry, which again? This
The first link you put on at timestamp
Okay.
904.
Okay.
I've used that and I've been very pleased with it. But I don't know that that's going to hold. Really, they say it'll hold 15 kg. I don't know about that.
Yeah, that seems like a lot. That's
35 pounds. I don't think I'd put 35 pounds on that one. Here, I'll show you.
Yeah.
I'll show you what it looks like in my hands.
Oh,
Because
good that I brought it up here. Yeah.
35 pounds. I suppose it could do that without breaking, but I mean, I don't know what you're thinking for size, but I have to tell you, they have some of these with plastic plates, acrylic, and this is the one with the metal.
Okay.
So I definitely recommend, if you're going to go this way, go with the metal. But what I like about this vendor is that they have a nice system with the wheel, the brackets, the motors, the cables, and then they provide these boards in here too. They have a Mega 2560 compatible motor board, and it's hard to see because I've added all kinds of junk to it, but the motor cables just plug straight into that motor board, the driver board, and so for not that much money, you can get a decent platform and start, like I did, strapping stuff on. So as you can see, I followed the duct tape method.
Okay.
I have a pill bottle, one of my dad's old pill bottles to hold the IMU, a BNO 065. Okay. I got these plastic standoffs from Amazon, and this is a what do you call it? Foam board style plate, easy to cut, and I mounted a NeoPixel ring.
Okay.
And I added just a 2-line LCD RGB display, some more NeoPixels, and then it's not connected right now, but you can get with this kit like a little RF dongle for the PS2 controller. Okay. So, I mean, if you go this way and you get this specific hardware set, I mean, I'll send you the link to my repos, and you're welcome to hack on the code.
Please, yeah.
I just don't know about like loading it down with 35 pounds and having something really tall on it.
Yeah, my plan is to put on a fan kind of thing, like motor rotating on top of this with a long rod. Maybe not that long, but I definitely can see that creating some kind of imbalance on this.
Yeah. There's another thing too, because for these wheels to work correctly, as many will tell you on this call, the weight distribution is critical.
Yeah.
So you have to have an even distribution of weight all the time on all 4 wheels. Otherwise, you might think the surface is flat, but it's probably not. And if
Got
it's
it.
not flat, so like we go to the Dallas Makerspace, right? And this one floor we usually meet in, there are spots on that floor where this robot goes, and two of the wheels will be holding it, suspending the weight, and the other two wheels just spin, and it doesn't go anywhere. It gets
Wow.
stuck on the floor because the floor is not flat.
Okay.
And this platform it's got this rigid aluminum plate. It doesn't have any suspension, so there's no way to keep the weight even on all four wheels.
Wow. Okay.
Yeah,
I would steer you away from omnidirectional robots,
Got it. Okay.
particularly Mecanum and even Kiwis, just about any kind of omnidirectional robot. You don't see them in the real world, and there's a reason for it.
Okay.
You see them in artificial environments where you have really, well, I guess really flat floors, or floors that have, some sort of treatment like foam or something like that, where it'll be, very consistent in the amount of friction that you have and things like that.
Okay.
Hey, Kareem, what about the like the Go Builda stuff? I mean, those are meant to handle a little bit more weight than some of the.
Yeah, you can get Mecanums that go up quite a bit. I have a set of 8-inch Mecanums, and they're rated for 120 pounds on each wheel.
Oh, I was thinking more about the U channel and that other kind of stuff.
The construction system.
Yeah, they in the 8mm shafts, they're a little beefier than that.
Yeah, you can get kits from Andy Mark, from Go Builda, from Rev that are capable of much higher loads, or in the range that Naveen's talking about. But it's not a starting. It's going to be more expensive than you're talking about here.
Several $100s,
yeah.
I actually used wheelchair motors because wheelchair may have to carry a 300-pound person, and the frames are built to handle that. And
that's a good idea. Yeah.
I looked at Craigslist. It's not too likely to find one at the makerspace. Occasionally they'll show up, but there's actually a place in Irving that sells wheelchair motors and wheels. They've been on Craigslist forever, but they're probably going to charge maybe $100 for a wheel motor setup. And with wheelchairs, a lot of times the wheels are specific to a certain motor design.
Got it.
So it's better to buy them, as one versus trying to piece them together from, different sources. So,
but if you search around, like you might try, like I just put a link, I just did a quick search, and I basically searched, I asked Google for AliExpress robot chassis 20 kilograms. And this one popped up for $120. It's a 50 kg load, full metal, four wheel kind of thing. Looks like it'd be tank drive, I guess, but.
Got it. But then how do you go about the wheels? And I believe the wheels and the motor should also be able to support it, right? I'm not able to open the link card that you shared.
Maybe. Let me
Doesn't
see
work for me either.
Let's see if I can get a shorter link, because that had all kinds of nonsense with tracking cookies and garbage.
Just give me the search string, otherwise I'll go with that.
Try this one.
Okay.
Or search for.
Yeah, I guess this looks like it's working. Yeah, I got something. Yeah.
Now that one's going to be skid steer.
Yeah.
Looks like.
Looks like.
Oh, it has everything. Okay, okay.
So it'll be differential, but the wheels have to slip a little bit because it doesn't look like there's actual steering on like the front or rear axle.
Yeah, it looks like the brackets would just have 4 screws each to hold the motor.
They kind of look like the motors can't be direct attached to the wheels, are they?
Could be. There might be probably a gearbox in there. Yeah. Oh, no, it doesn't. Oh, yeah. I don't think the motor shaft comes out of the center of the gearbox. It's offset.
Yeah, that's pretty common. So those are, yeah. It's not a, I would never recommend, especially on a 50 kilogram load, to mount
skid steer like that. Yeah.
To mount the wheels directly on the motors. They should be freewheeling on a stronger shaft.
Yeah, maybe ball bearings or.
So I can connect this to an Arduino or Pi and do my programming, right?
What?
I can connect this to Arduino or Pi and program the motors, or
You have
There's
to have
no
a
motor controller in there.
Yeah.
Yeah, you have to buy it separately.
There's
Carl,
no
did
electronics
you buy
there.
yours separately, or did it come with it?
Well, mine, the vendor that Naveen first showed that I've used, I mean, that's what's nice is that they have a good platform with the electronics and motors. These are just bare motors, and then it doesn't even look like they have encoders. So there's a lot of things working against you with this. But that's where what we found, Naveen, is that a lot of the guys in the club we're at the point where we just like to start from scratch.
Got it.
But then there's some of us who will kit bash. We'll find some kit that's more or less close, and then we'll hack on it.
Got it.
So, like if these had encoders, if you're willing to mix and match, like I would be tempted to take some of the electronics from that vendor you and I were talking about, this Moebus,
Okay.
and take the electronics from them, and then maybe even the motors, but then find just a pair of differential wheels and a caster from somewhere else.
Got it. Okay.
And
try that
that
out,
you
yeah.
can minimize the kind of things you have to build from scratch, and that'll help you out, because if you try and do everything from scratch, it'll take a long time.
Yeah. Thanks for this, everyone. I'll start with this and see how far I can go.
Another good source of wheelchairs is retirement homes around lunchtime. They try to get out of the chairs and, take off all the personalization stuff, the tchotchkes, and drive it away.
Just wait till you see an ambulance pulling out.
There you go. There
That's
you
the
go.
morbid.
And an empty wheelchair sitting somewhere.
Oh God.
Naveen, I really appreciate you putting in that link from Mauser. That's the cheapest thumper I've seen, 6-wheel thumper I've ever seen.
Okay.
Usually they're slightly different design, but they're also much more expensive. So that's kind of cool.
Thank you. Is there a way I can estimate like how much they weigh, but just by buying it and putting weight on it? Is that the only way I can do that? Any of these pre-built robot kits?
Well, the problem you run into is you have to make sure, like Kareem mentioned, if you're driving straight off the motor shaft, if you have a motor shaft coming out of the motor and you're putting a wheel on it, there's only so much weight because that gearbox will not, in general, there are some, but in general, it's not good at taking lateral loads, and you'll end up with a mess after you run it around a bit. So usually what they do is you run them indirectly So you may have Dave Anderson, one of our members. He has a belt drive that goes down to one set of wheels, and the wheel itself is just the wheel, a bearing, shaft, and a bearing, and in that, between those two bearings, he has a pulley, and on that he runs a belt from the motor down to the pulley, and then to drive the other wheels on the side, he has another belt that goes to the next wheel. So that's one thing. And what I was talking to Scott earlier about, if you have any sort of suspension, somewhere you're going to hit some sort of weight limit where it essentially just all the springs and everything just sag down to where it's completely exhausted. You don't really have a suspension anymore because it's all the weight has already pushed the suspension down as far as it'll go. So there's some, so can you model those things? Yes, you can. But most people in the hobby world, they kind of like keep it light.
Got it.
Yeah, this is a the post.
I just pasted a link to that 6-wheel car from the Seed Studio website, and there's a video there that shows a guy depressing it. It won't take. It's very small, and it won't take much.
Oh, thank you. Yeah.
Yeah, I think it's not as big as it looks in the first picture.
Okay, so it's not a full thumper then, you're saying?
No.
Okay.
Okay. Anyway, to Doug and Carl's point, these are motors that I've used before. They're seat motors, and it does have a worm, like automotive seat motors, a worm and a worm gear drive here, but it's only, I don't know if you can see that, but this shaft wiggles a little bit, and when I used it, I actually put 2 bearings on it, one there and one, well, actually
Holding up Ray, we can't see it.
Oh, sorry.
Yeah.
Put 2 bearings on it, closer into here, and mounted the wheel out over here. I actually extended that out, but
So your gearbox isn't taking the load.
Yeah.
Right. Yeah.
You got a fork in there with 2. Yeah.
Yep. So, and this is like a 7/16 shaft, but my wheels were 3/4 inch, and so I just bored out the shaft to like press fit on this, and it's worked fairly well. But it's got ball bearings with seals, and I took a lot of time to make a milling machine and to mill out all the bearing holders, so out of aluminum. So it takes quite a bit of time. It's certainly not something you can just whip together in a few months. It's
Got it.
Hey, Ray, have you ever had any trouble with, those motors are meant to be not used continuously.
Yeah.
For our loads, do they do fine continuous?
Yeah, I'm loading them a lot less than, it's not lifting a 300-pound person in a seat or moving the seat forward or backwards or something. But, when, the currents are a lot less, and,
You haven't had any problem?
No, not yet. I don't know if the heat wave continues into the contest time, I might have some issues there. I don't know. So.
Thanks everyone for your inputs. I'll keep searching for that.
Yeah. It's surprisingly hard to get what chassis for your job,
I know.
I mean, it just is. That's why I think a lot of us like to build them we finally get to the point where we just want to build them ourselves.
Got it.
Yeah. But if you don't have the tools and you haven't ever built anything like that, that can be a real journey.
Yeah.
You may end up buying that platform anyway. So
Yeah.
Now, having built a lot of stuff, and probably the least competent builder as far as our group goes here, I can tell you why I want to build these things myself. Is because invariably I want to do something that other people on the planet have never thought about doing and not coded it up so I can just do it.
I know, right? I know the feeling. Yeah.
That could be me. That could then I got to check myself. Am I doing something just overall stupid that I don't need to be doing? I ask myself that. Sometimes the answer is yes. And so I'm like, okay, let's not do that. And sometimes it's like, no, I really need to do this. And so I end up spending way more. Well, I got to learn much more stuff anyway.
I got an idea for you, Harold.
No.
Pooper scooper robot.
Pooper scooper. I thought about that.
There was a point in my life when, I was actually working towards that. It was an important issue, but it no longer is. So.
No longer is.
Yeah.
There is a, he's working for, who does, he's working for a message, it's kind of a messaging company. I forget what it is. It's not, Twilio. He's working for Twilio now. He used to be an MVP, and he may still be. I ran into him several years ago, and what he had done was he put a camera on his toilet. Okay? And then he trained his cat to use the toilet instead of a litter box. And then he used AI and did a little vision on the thing, determined whether the toilet needed flushing or not. And so he built that whole thing, artificial intelligence, the whole stuff. He can flush his toilet from his phone, when he's in Hoboken, New York or something, all that kind of stuff. He did all those stuff.
I got an innovative cat and dog outdoor poop photos.
Kareem, would you like to be the outdoor poop scooper robot repairer?
Sounds like a future career.
There is somebody who is dabbling with joining DPRG about 6 months before COVID came along, and she spent like a couple of months working towards a design for a pooper scooper, but her pooper scooper was basically one of the hexapods, and she was going to use it like the. So we were trying to explain to her, think about this for a moment, but.
Yeah. Well, for what it's worth, my daughter actually pays somebody to come to her house once a week and pick up all the dog poop.
There you go.
See, there's a market there.
There is.
I was desperate to not be doing that myself.
That was my job in high school. My sister and I had a little company, and we'd go around the neighborhood.
Seriously.
I'm just curious. I mean, I know drones are not there yet, but why not use drones instead of doing anything that touches the ground? Like, I know that might sound like why can't robots not be flying around and not have bipedal, quadrupedal, or wheels or anything?
Do you mean in this club or in general?
In general. Like, what are your thoughts? Like, why can't we have something that goes around, scoping the poop, just flies around for like 10 minutes? I know that they can't fly for longer, but
flying poop on?
A pretty good size drone to scoop poop.
So you talk about loads.
Yeah.
Well,
Guilty.
Yeah. Anyway,
It always comes down to potty humor.
Yeah.
I got a question for Scott. If everybody's done,
I want to try and give a semi-serious response to Naveen, and that would be that, just think about it. It seems that like these delivery bots, it's taking them some time to come up with systems that are robust enough that they can deploy in really limited situations.
Yeah.
To take up well-shaped packages and deposit them in more or less the right location. And that's a difficult enough problem as it is. I can only imagine if you try and turn that around to pick up things that are not well-shaped packages.
And sort of stuck in the grass.
What a great question, though. I think that's fantastic. I love it. It gets the creative juices flowing, doesn't it?
It certainly does have agricultural, implications because, you don't want your cow patties to just sit in one place in the field. You want them dispersed. So, that's the other way to think about it, right? Think about all the Roombas, right? The Roombas are just meant to scoop things up in living rooms and such, but when pets leave little deposits scattered around, what does the Roomba do? Spreads it thinly.
So is this going to be at one of our new contests? How well can you pick up and move something to somewhere else?
We'll call this contest the Hit the Fan contest.
I like it.
Doug, how about some rules?
Probably have to use like synthetic poop or something.
Well, it's just not. But the thing is, it's synthetic, sure, but there's a consistency issue with the poop. Because some of them are more solid and some of them are more runny. You got to take all that into consideration. There's got to be some rules for that.
Okay, I think Pat was going to ask a question.
So I had a question for Scott. Just impressed with the some of the metal work on his robot that he was showing, and wanted to just get a little more information on that. Did you buy that? Did you build it? How did you manage to make it? Because it looks like first class to me. Really, really well done.
Well, thanks. No, that's all hand built. I have, a shop with, I have a pan brake and a corner notcher and some other tools. So, I don't know. I've been working with metal since I was in high school. So, but see, I don't take pictures of the stuff I screw up. So,
well, it looks very well made. Anyways, I was impressed when I saw it. It looks like not a homemade application. It looks like a professional, something you would ship out on a already made product. Here you go, ready for the mainstream.
Well, I appreciate that. Always enjoy time out in the shop, working with your hands. Yeah, I enjoy that. I think more than writing software. So.
Yeah, me too.
Thank you. That was it. That's it for me. Well, I could present. I got another little thing. I got a link. If anyone's interested on the new Arduino R4.
Yeah.
So I've been looking at converting Arduino code to run it, and there's not all the applications I believe are done yet for that. I'm just going to paste the link into it. So what I was looking at was, because of the 5-volt I/O and everything is the 5-volt I/O is basically a drop-in replacement, at least voltage-wise, for an Arduino Uno. But the question I had was the pulse width modulation frequency for driving motors, let's say. And I came across this link after a lot of searching, and it took me a while to find it. But basically talks about how to set the timer registers to enable different pulse width modulation. It goes quite in depth, and it's just the information I was looking for. It just so happened as well while I was looking into that, when I was working on CANbot earlier this year, and I wasn't getting any luck trying to get CANbot to turn, like to go out a certain distance, turn 180 degrees and come back. And it was the pulse width modulation, I believe, on my motors that was giving me the problem. I was using the default 490 hertz on the Arduino, and I believe that's why I couldn't get any low-end torque on my motors. So I kept overshooting, trying to correct back to zero. I kept overshooting, and I was severely oscillating back and forth past my zero mark. That's it for me. Just a little info I spread around that I had trouble finding.
Cool. Thanks for sharing.
Yeah, there were actually two different frequencies that the PWMs put out. Like on the Mega, pins 2 through 13, 44 through 46 use 490 hertz, but pins 5 and 6 put out 980 hertz. So it's about twice as much. Twice as fast.
Yeah, so after looking it up and talking to you guys over the few weeks, as fast as your motor driver will take the pulse width modulation frequency, the better it is. And so, looking at different drivers, they'll go up to, 20 kilohertz or, 12 kilohertz or something, which is, way better. And then the motor will also see a nice, more of a smoother voltage as it's going across. So that, at least it gives me some hope for my next robot when I found this. And doing a little more digging around into my outdoor bot, I'm using a Pololu VNH 5019 dual motor driver, and it already bumps up the frequency to 20 kilohertz.
That sounds good.
So the motor does that by their driver does that automatically on the Uno, using pins D9 and D10, which is standard on the board. And they also have a newer driver that works on the Mega, because the Mega has different timer pins in those locations, and so they've developed the code for the Mega as well. Those of us that build bigger robots need bigger motor drivers.
And wood.
Of course.
Well, cool. All right. Let's see. Okay. Well, how are we doing? Are there any more open mic topics du jour? Going twice. All right, guys. Well, I have to say, this is a pretty fun discussion, even when I talked about robots. So that's awesome.
Have a good night, guys.
Have a great week.
Bye.
Talk to you later.